Good evening, everyone. This is Robert Pultz, and this is the second video on my lunar moon-based service, and this is going to be about the lunar lander, which is the MRLL. The moon base is called the SLC, and we'll start sharing. According to this, you should be seeing the first slide. So this is the overall idealized drawing of the various services that will be offered at the moon base. The SLC collaboration, this is a science fiction effort of mine about science fiction. I'm hoping that there will be a collaborative effort here and people will give me their ideas and tell me whether this is a workable solution. I imagine that's going to happen when I get into 3 or 4 of these basically videos that are chapters. And it's not a traditional sci-fi story. It's going to be written as a series of business and marketing and sales plans with estimates of timing, cost, and revenue generated. And like all of these, it's going to go through an iterative process. You're going to lay out a framework out there. It's going to be what we used to call a straw man. People are going to take and comment on it. I'm going to comment on it as we go through it, and then we'll take and redo estimates. So the numbers that you'll see will be the estimates, and the timing that you'll see will be the estimates at the time it's written. And as we go along, there will be an iterative process where it'll be fine-tuned and honed to take and do it. One of the collaborators that I'm using is AI or Gemini. And so I'll have an AI assistant in addition to hopefully some human assistants out there. And I have established a YouTube playlist, and there it is on the screen for these. So you can take and follow them one right after the other. They'll be numbered in sequence. Hopefully, I was trying to think and remember how I named these. We've chosen a target destination. It's the northwestern ridge of the plateau Shoemaker Crater rim. Chose that because it has at least from the knowledge that we have today, it's not currently being claimed by any of the international organizations that I know of yet. That may change. And it's in the southern end of the moon, where there's supposed to be some water and possibly some of the other materials that we're looking for. And there's been quite a few studies on it. It's a 51-kilometer crater. The bottom of it is in permanent shadows, which makes it opportunity for water. Here are some directions. You can read those as well as I can for finding them. Here are 2 URLs that I found about describing it. One is very interesting, a NASA PDF about the crater and what they have found there and what work they've done there. And they've done quite a bit as prep for this. So it looks promising. I don't know whether it will or not. And then the Wikipedia article on it. The financing company or the company that this will take and be built under is called the Lunar Base Consortium. And it's assumed that the Lunar Base Consortium, before any of this starts, will have secured the exclusive legal rights to explore and mine the entire crater and a substantial portion around it, because we're going to be tunneling into that area. So whatever the international bodies are or the international process is, it will be assumed that that's occurred. And so we have legal right to this crater, and we can take and exploit it for mining purposes, for the various services that we plan on providing to other organizations out of this crater. Okay. Suddenly, Project SLC introduces a paradigm shift in deep space logistics by developing a modular reconfigurable lunar lander, MRLL, that functions as both the transport vehicle and a harvestable source of raw materials, while the primary objective is to minimize the cost per kilogram of deliverable material to the lunar surface. What do those big words mean? Well, it means that the ship itself can be repurposed. The materials that make the ship, they're not lost, in addition to the payload. So you have the payload and you have the ship that you can take and disassemble and reassemble as functioning parts on the planet. For instance, just to give you an example, the solar panels that are on the sides and the top of the ship will become the solar panels that are part of the solar panel power unit. Okay. The batteries that are in it will be bought batteries, bought um, standard batteries that are configured so that the ship can take and run on. But then they will be on the bots, on the 3D printers, and all the other instruments there, and they will also act as storage for the solar power supply. Those kinds of things. So everything's reused. Um, the biggest thing that has a time delay on reusing it is the actual motors that are driving this into low Earth orbit. And so those are being stored to take and repair spaceships in the future, and also to take and make heavier lunar landers as needed. But we'll have a surplus of those. Okay. Current estimate for this launch. This is the first. We're talking about the first launch and also the launches thereafter. So you can get that all from here. The launch services for Super X Super Heavy booster for suborbital insertion is about $40 million. There'll have to be orbital logistics where LEO tankers are set up for refueling flights. That's a variable number. So I've taken the worst case scenario here, and hopefully that's close to it. We will learn over time whether it is or not. And then the actual spacecraft hardware, the fuselage, modular tanks, and stuff like that, are expected to be around $120 million. There will be a one-time integration fee. We got to take this is something that's never been done before, so it's got to be tested and the flights and stuff like that have to be tested. And it looks like it's about $87 million to do that. That'll be one time. That'll be the first time. It's not to say that there might be some recurring expenses if this doesn't prove to be optimized. But at this point in time, that's not identified. So the first trip is about $472 million, with a $385 million for each additional one. That means that you get the ship plus payload of 100,000 kilograms or 614 cubic meters of payload. That's quite a bit. There are, payloads from the Apollo days that you could put most of the rockets in there, in addition to the payload. So that's quite a bit of material, and we're going to talk about how we're going to use that. Okay. Technical system architecture. The core airframe is advanced aluminum-lithium interlocks space truss matrix of standard parts. Okay, we've talked about standard parts in the first. So now this is infrastructure standard parts, and we will have beams of a certain length that have holes at certain places, or that can be drilled in certain places, so that they're all standard parts, and they are repurposable. So these beams will be taken out. The side panels will be either solar panels or blank panels that can be used as bots, the body of bots. And so the entire structure of this ship can now then be disintegrated and reintegrated as different parts. And as you get through here, you'll see a discussion about garages later on. The garage will be like the last third of the ship, of the container part of the ship, so that we have a dust-proof place to take and assemble stuff and work on stuff And the door on it will be basically one of these blow-up bladders that we're going to have nitrogen in. We'll talk about in just a minute. And so that'll give us a dust-proof place to take and assemble products and work on products until we actually have our tunnel done. Okay, the lithium-ion interlock space truss will be disassembled and repurposed to bots and other infrastructures on the moon base. Think of it as an interrupter set that in transit is one application, at the lunar base is disassembled and repurposed to another function. So I'm trying to explain that. I hope I'm doing a good job of it. Payload components are secured inside of the ship itself using nitrogen structural airbags. So basically, you'll put your components in there, your payload components in there, and then these airbags will be blown up with nitrogen. Nitrogen was chosen because of fire hazard. If I chose oxygen, and we had a fire, it would feed the fire. So Jim and I had a long discussion about that and came up with nitrogen. There will be a vacuum pump system that will reclaim these bags, the air gas in these bags. They'll deflate the bags so you can take and pull the pieces out, and the gas will be stored and buffered for other uses. Like, for instance, when we're trying to make Earth-like atmosphere later on. Upon Earth takeoff, the landing motors are going to be stored inside the lander. There will be a hatch on the top of the lander someplace, either on the nose cone and possibly on the nose cone. That's where I envision it at the moment. There will be robotic arms that will be removable and work on the outside of the ship, and they will take these landing motors out of the ship and take them to the appropriate locations and install them. And they will also install the lines, the fuel lines and the electrical lines and the control lines to these landers. The reason for that is aerodynamics. When we're taking off, we don't want a lot of things stuck on the outside. And this way we will be able to take and do these lander motors. These lander motors are rotatable 180 degrees, and they can gimbal out some. So you can take and adjust the angle for taking and bringing in the ship. Should be a fairly soft landing. Remember, we're landing on the moon's surface. We don't have a pad for the first one. We'll talk about how building a pad later on. Okay, day one of the launch, we'll be sitting on a SpaceX Super Heavy booster, and it's going to insert the MRLL into low Earth suborbital velocity, at which time the MRLL's motors will take over. Could be 6 core Earth escape transit engines. That's what is on the current spacecraft. But of course, they are not MRLLs, but they are similar in size and payload. So these engines will create the escape and establish the ship in low Earth orbit. The next day, we will take advantage of 15 low Earth tankers that have been launched and are in parking orbit waiting for fuels. By the time we actually do this project, it's expected that this will be a standard SpaceX service offering for refueling various people's spacecraft out there for a fee. We're estimating the fee based on some of the information that we have acquired from SpaceX notifications. But if SpaceX isn't doing it, Blue Orion, there's several other companies that need this service in order to take and make the trips that we're talking about making. So it's like a gas station in the sky for a thing. The tankers will top off the MRLL's matrix of standard 12 spherical propellant tanks with liquid methane and liquid oxygen. So we are using liquid methane and liquid oxygen engines on there in all cases, the landing and so on. if we have customers for our ion tugs to take and so we can take and harvest scrap that we'll take and use on the moon. Um, yeah, I don't expect it on this first ship, but eventually this is where we would start deploying the ion tugs. Basically, the deployment will be determined someplace on the transit on where the target is located at that time. The closest we can get to the target to deploy the ion tugs, the better, and then they'll start dragging those devices towards a lunar orbit where we will collect them later on, uh, the raw material later on. And our intention there is to take and harvest second stages and spent satellites that are basically junk harvest out there, and to sell that as a service to organizations that are being required by international bodies to take and remove space junk. And so we're going to take the space junk to the moon where we can use it as raw resources, and we're going to use the lowest possible way of getting there, and that's going to be ion tugs at this point in time, and we'll use solar power to power the ion tugs. And it may take years to take and move a fairly large object to where we can bring it down to the moon and harvest it. But we will, invest that time. Day 6 will be lunar transfer injection. The MRLL will start its core engines and transit engines and fires towards a weak stability boundary. Now, this route to the moon has been chosen, even though it's a long. We pay it consumes a lot of time. But we're not concerned about time as we are about the cost of getting it there and the maximum payload that we can deliver there. So the fuel that we save on this will be part of our lunar base refueling station. So this base will be able to take and refuel spaceships. It'll be able to refuel hoppers. It will have a fueling capability. So in addition to taking and repairing spaceships there, it will also be able to take and refuel spaceships there. So we're like a gas station on the moon for spacecraft. Month 1 to month 3 will be the transit. It takes that long when you're going in this particular route that is low fuel consumption. The internal robotic gantry system that's the arms, will reclaim the nitrogen airbags from the storage around the landing engines. So that'll free up the landing engines. Then they'll start transporting the 8 landing engines out and start installing them on the outside of the ML, the lander, so that we can take and land on a horizontal position. And so they'll get on the external thrust mounts. They'll connect the fuel lines and guidance and control, all the power and everything else that these motors need. I envision tie wraps running up and down the side of this thing. There's no reason why not to use them out there, out in space. There's not a whole lot of wind and aerodynamic things that are failing with you, so it's a possibility. Month 4, about 120 days, on flight 1 only. This is the first flight only. It could also involve later flights, but we will be at that point in time installing the satellite constellation of 50 data satellites. These satellites have GPS, lunar GPS. They've got internet services, and they got imaging. They've got cameras on there for doing imaging. Okay. And there will also be 2 AI data centers on there. One is a backup to the other. I don't like to have one a single point of failure, and the AI will be basically managing everything that the moon base does, and it will be also coordinating the communications back with Earth. So it'll actually be the gateway for data and finding bandwidth enough to take and ship back project. Now, once the data satellites are installed and the AI centers are installed, we now have a billable service that we can start selling. So we'll be doing a marketing plan and a sales plan for those at this point in time. So this is roughly 4 months after the launch. We'll probably be doing from the launch on. We'll probably be doing marketing and sales. We still got to write that. Okay, the fourth month plus 2 days. These are all estimates. We're going to do a horizontal touchdown on the moon. Now, this is a lightened MRLL because we've taken the satellites out of it, and we've also taken the ion propulsion units out of it. So this is a unit that has delivered two services possibly by this time, and maybe even, yeah, I can't think of any more right now. And we're going to come in for a horizontal belly landing. Now, one of the questions I have is whether we should put a skid on the bottom of the unit to take and skid in, or whether we think we can take and actually pancake it down. I'm for pancake right now. So it'll come into the northwestern rim of the plateau of the Shoemaker. Reason why we're choosing that is that rim has sunlight on it all the time, or the majority of the time. So that's a good place to put the solar panels right above where we're going to take and drill in for the tunnel. And the reason why we might want to take and consider that is that we've got a temperature problem. The temperature on the moon varies substantially, but we can take advantage of solar heating and heat the inside of the tunnel if we need that. And that may be, that's one of the things we're gonna have to learn. Okay, so it's been released. The MRLL has been lightened by the release of this stuff, and that's important because we're coming in with 100 tons of material, which is less than 100 tons, but near 100 tons of material, and dropping it down on a land, lander on the moon. And there we go. And so, and we don't have a landing pad because that's one of the first things we've got to do when we get there. And so, anyway, that's what's going on. Okay, non-lunar infrastructure that we've built with this process. We have an unknown number of ion propulsion tugs currently migrating raw materials towards lunar orbit. This may take years, and that's probably no exaggeration. Ion propulsion is a very slow starting method that can get to be very fast. But anyway, we want it to take and have the structure to take and bring this information into, or this material into lunar orbit, where we can then harvest it and bring it down and work on it. We have 50 data satellites up there with GPS, internet, and imaging capability. All those services can be sold to other parties. Plus, they're key services for us. The GPS is key for when we go in and land this first ship. We'll be using that GPS to coordinate our position. And we'll have 2 AI centers, and that will be local AI data centers for operations. Anyone's operation on the moon will be very, very essential. So this is non-linear infrastructure that we will have in place at that point, and it's revenue generating. Lunar inventory after the trip. We'll have 6 core Earth escape transit engines. Now that may vary. We may see that we don't need 6. Right now, I'm going conservative, and I feel that 6 will be needed. Part of that $85 million will be to take and determine how many engines we're actually going to need. They're available for spaceship repairs, which is not probably going to happen for a long time. So they'll basically be stored in a environment that will take and limit their damage. Biggest concern about damage would be the particles on the moon getting into the engines. And so we don't have anything built just yet. And so these will be out in moon space, and they may eventually have to be scrapped. Then we'll have eight lunar lander motors. Now, four of these will be slated for the cone of the lander, that it will be made into a hopper. And so four of those, one on each leg, will be needed for that. So we'll have four lunar motors that we take over that. We'll have two then, or four that are spares. Now, it's conceivable that we can make another hopper from the materials that are in the ship. We'll have to take and see how that all works out. Uh, I have other applications for some of the material in the ships, but at some point in time, we will have extra material from the ship, and then we'll have motors that we can take and add to the lunar hoppers. We'll have a 3D printer. The first payload is going to be a 3D printer. It's going to be capable of converting lunar Regenauth into a launch pad, a refueling station, and a road to the tunnel. Yeah, there we go. And other infrastructure. So that's using basically the materials that are on the moon to take and build infrastructure. It's to take and feed the 3D printer. We're going to take and have two Regenauth Advanced Surface Systems operations robots. They're called RASSORs. They're purchasable today. Designs are purchasable today from a third-party source. 3D printers are soon to be purchasable from another source too. And then we're going to recycle the solar panels on the sides and the tops of the lander, the MRLL. We will take and remove the panels, and then we'll reinstall them, like I said, on the surface of the crater, on the edge of the surface of the crater where the sunlight comes in. So they'll be moved up there. Okay. We will have bought standard battery packs, and they're the standard battery. They're the batteries that the ship used for its electrical power on the way up. Its storage for the electrical power up there. We will have at least one for each of the bots. So we've got two of the RASSOR bots on there, and then we have the 3D printer. It'll probably take more than one on it because it's got a laser on it that's got to be heated up. And then we'll have some for solar panel storage with that at this point in time will be installed near the solar panels, but at a later date will be installed actually inside the tunnel because of temperature concerns. And these will be all these batteries will be repurposed from the MRL's power supply. All the batteries will be the same. So far, right now, I think I can do that. The number of structural standard elements for construction bots, there will be a lot of components. Basically the ship will be filled up to its 100-ton capability, or 100,000 kilograms of capability to take and be various bot construction parts, the motor units, the tires for the bots, the arms for the bots, and that number will be variable based on how many ion propulsion units that we have contracts for at the time, and that goes on for each time, each launch. It'll the available space will be filled with standard components to take and construct bots, construct floors maybe in the tunnel, and then the last piece will be tools, parts, and assembly for assembling bots and repairing any of the above inventory. So anyway, and any forecasted failures of the standard parts. Now that's one of the features that the AI has to do. It has to keep track of when each one of these bots is used. Okay. All right. Um, Please like or subscribe if you wish to receive notification of future installments of this sci-fi business plan, or basically sci-fi plan. There's a separate playlist which I've listed in here, and comments on the plan are going to be grateful. You probably want to wait until 3 or 4 of these videos are out to see where I'm going with this. Here's some of the things that I'll be doing. Here's the satellite constellation. Here's hotel sleeping pods. We'll be offering hotel services. Here's what a bot may a suggestion of a bot. We'll have standard tires and standard motors on all the bots, and a solar panel power system. So that's basically where we're going with this. Okay, let's see if I can get everything to work here. I appreciate your time. I really do appreciate everyone that takes and and reads my sci-fi, and I'll appreciate anything that you have to say back. Have a great day.